In this video, I talk about control structures in Matlab, which are loops, branches, and switches. Let's start with loops. Now, before writing a loop, you should check whether the code can be vectorized. You know that Matlab is a highly vectorized language. You can call many functions with vector arguments, in which case you do not have to write a loop. But the loop is, of course, invisible in the code, in the precompiled code. So normally a precompiled loop in a vectorized function is much faster than an interpreted loop which you write yourself in Matlab code. Now let's start with for loops. I mean, in some cases you do need loops, so you have to know these constructs. There are two kinds of loops, the for loop and the while loop. Let's start with the for loop. Please open the script example control structures and put a breakpoint in line 5. I now start execution of this script and it will terminate, pause immediately in line 5. Now the problem here is to sum over the first n odd numbers where n equals 10. Now, of course, this would normally not be done by a loop. This is just for the purpose of demonstrating how to construct such a loop. So I set the sum, the running sum, to 0, and now I define the values, capital I, which the loop variable, small I, is supposed to take when it runs through the loop. So small I runs over the values in capital I, and capital I in this case is a vector, a row vector. It can also be a column vector. Now the statements inside the loop should be executed exactly 10 times for each value of small I. Now let's show this. And you see that I display the current value of sum I with the help of this dist statement. Now let's just step through the loop a certain number of times. Every time the running sum is displayed. And when small I runs out of values in capital I, the loop is terminated and control is transferred to the line after the loop, which is line 12. You see that you have to terminate the for statement by a corresponding end statement in line 11. Now I can display all the cumulative sums by using the function CumSum, cumulative sum. This is the way you should normally do this. Do not write a loop, but just use the function CumSum or CumSum with the argument capital I, and this will do effectively the same, and then you can display the cumulative sums, which are just the squares from 1 to 100. So this is the vectorized version. Now let's do a similar thing with a matrix. Let me generate a random matrix, a matrix with uniform random numbers between 0 and 1. I set the random number generator to its default value. I set the seed of the generator to its default value. And here we have this matrix of random numbers. It's 4 by 10. Now I want to solve the following problem. Let me compute the column sums of this matrix. This can also be done, well, it should not be, but it can be done with a loop, with a for loop. And in this case, the control variable of the loop, the variable c, runs over the columns of A. So if the right-hand side in this equality is a matrix, the left-hand side will run over the columns of A. So if I execute this loop, the matrix has 10 columns. So this statement in line 21, this command should be executed once for each column of A, which is to say it should be executed 10 times. Now let's step through this loop. In line 21, I compute the column sum of the column C and I append it to the vector SA. So in the end, we should have a vector, a row vector, with the column sums of A. So let's step until the control is transferred to the command, the statement after the loop, line 23, and here I can display the vector SA of the column sums, which you see here in the command window. Now this can of course be vectorized, as you know. The function sum, if you apply it to a matrix, computes the column sums. So I just call the function sum and I get again the column sums of this matrix in the vector SA, and this is of course the same as before. The second kind of loop is the while loop. It has the following form: the function while and then a logical variable. And the loop is executed as long as this logical value is true, which in this case is always true. I use this while loop to enter a number. The loop is terminated if this number is empty. So if you just hit carriage return, then the X will be empty and the loop will be terminated by the break statement. Here you see an if statement, which we'll talk about in a minute. So break will terminate execution of the loop and transfer control to the line after the end statement of this while loop. So let me execute this while loop. Let's step into it. Since true is by definition true, we enter the loop, the body of the loop, and now the script asks for entering a number. I will do that. So I get this prompt in the command window and I enter the number 2.5. Now if I execute line 30, X should not be empty. In fact, X should be 2.5, correct. And I I want to compute the exponential function with the argument x by summing its series. Of course, you would never do this in a real life situation. This is just for demonstrating the properties of a while loop. There is, of course, an exponential function built in Matlab. We will see that in line 41. But here I want to show you how you can sum over the series and terminate when the element of the series is smaller or equal to the number epsi, which is a kind of epsilon. It's 10 to the minus 8. So if the current value of the series, of the elements of the series, is smaller than 10 to the minus 8, the loop will stop. So let's step through the statements. Here's the counter n, which is incremented in this inner while loop. And this inner while loop does the job of summing over the exponential series. This is a well-known procedure to compute the exponential series and to sum it. And this will go on until the current value of y, which is the current element in the series, falls below 10 to the minus 8. This takes a few iterations. And you see the running sums in the command window. Takes quite a few iterations to get the desired precision. You can also set a breakpoint after the loop and then just click on the continue arrow. This will let run the loop until this condition is false. And then the control is transferred to the line after the end statement of this loop. And you see the result in the command window. Of course, in a real life situation, you would never do that. You would just call the function exp, an elementary function in Matlab. We'll talk about that later. And you will see that you get with the same result within the desired precision. Okay, this demonstrates the use of a while loop. Now, the outer while loop is still active. So if I now step to line 29, I can enter another number, or I can enter, or just hit carriage return to stop the execution of the outer while loop. Now let's do that. Here's the prompt. I do not enter a number, I just hit carriage return to stop this loop. Now x is empty. The break statement or the break command now transfers control flow to the line after the outer loop. Now let me demonstrate the if else end branch. Here's again an outer loop which asks for a number or carriage return to stop. So let's enter this while loop. So let me enter the number 0.6. Again, if this number is empty, so if I just hit carriage return, the loop terminate via the break command. Let's go on. And now I have a branch. If the number entered is negative, I display a less than 0. Now this is obviously not true in this case. So I go to the next question. Else if a does not exceed 1. Now this is true. So the string a is between 0 and 1 is displayed in the command window. Since this is true, transfer is controlled to the end statement of this branch. So if end is a branch, and depending on the value of the logical variables, after if, else if, the corresponding line is executed. If all these conditions are false, the else statement, which is to say the line after the else command, is executed. So let's try with a number which is larger than 1. In this case, a greater than 1 should be displayed. Now let me just continue. I set a breakpoint here. So I enter now the number 1.2. And you see that the script displays a greater than 1. Now I stop by entering a carriage return. And the loop is terminated. Okay, this is a branch, so you specify conditions, and depending on these conditions, the appropriate action is taken. Control is transferred to the lines in the respective branches of this if, else end construction. Okay, if you have to distinguish between several cases, it might be easier not to use if, else end, but to use the switch function or the switch command. Let's execute this part of the script. So let's run this section. No, let's first set a breakpoint here. At this point, let's terminate the execution and run this section again. So I have to enter the name of a day or carriage return to stop. Actually, I don't need to enter the entire name of the day. You can see that I have to enter 3 characters, at least 3 characters. And then the switch command will execute one of the cases which are listed with the keyword or the function case. You can also specify a switch to the line after the otherwise, which will be executed if none of these cases actually is true. So let me show you how to do this. I enter the name of the day, let's say Monday. Now, if the day is empty, then I again use the break statement to terminate the loop. If there are less than 3 characters, then I output type at least 3 characters, and then the continue statement or the continue function will pass the control immediately to the next iteration of the loop, which is to say it will skip the switch statement, everything that's after the continue function, and go to the first line of this while loop. Now in this case, day contains the string, now the character array Monday, so it should display this string, today is Monday. You see that I use only it's not case sensitive. So I just use the lower, smaller character version of this string, which is done by the function lower. So lower day 1, 2, 3 is the first characters of this vector, this character vector, converted to lower case. And this is what I use to distinguish between the 7 cases. So in this case, the switch corresponds to the case, and the line after the case statement is executed. Let's continue. Now I can input a string with less than 3 characters. If I just enter SU, then I get the message type at least 3 characters, and I'm asked again. So let's now enter the string SON. Now this string does not correspond to any of these cases, so the line after the otherwise command should be displayed. If we step through this, you see that all cases are checked, none of them is true, so the line after the otherwise function is executed. SON is an unknown day, and we continue with this while loop, which is an infinite loop actually, because true is by definition always true, and I can stop execution now either by Control C or just by entering an empty number, and the execution will stop.